And welcome everybody to the Daily Space Weather. I'm Dan, your host, aka smAsho. And what we're looking at here is a 171 angstroms SOHO movie of cycle 25 to date. So it starts out in about 2 days before the beginning of cycle 25, back in mid-November of 2019, and continues to now. You can see right at the end of the video, you'll see 3 significant sunspots go right across the northern hemisphere. And we just experienced those in some fairly decent detail on the channel. So we've got a pretty good one today. There's a whole bunch of interesting material to cover. And I think you'll enjoy it. I'm not sure how long it will be. There won't be a smashlight segment separate from the regular video. So we'll be talking about coronal mass ejections, which continue, CMEs as they're known. Also the Galactic Wind, for instance, if it's a thing. We'll talk about geomagnetic storms and unrest continuing. And we've gotten to the point where we can't parse the difference between coronal hole wind streams and coronal mass ejections at this point. A great example of how the sun doesn't need to have sunspots or X-ray flares to produce lots of activity at the same time. So we see coronal holes leading this plage. We see a bunch of ejecta coming off of it here. Just make sure the stream is live here, as we are streaming live to Twitch. It's twitch.tv/smAsho. And you can actually see a coronal mass ejection right there at the end of the video. And there's a whole bunch of ejecta headed this way, as well as coronal hole wind streams. So the coronal hole wind streams continue, and at the same time we see a big increase in the electron flux. Too much stuff going on to really cover, even in a 30 to 40 minute video. I expect today's will only be about 30. We're going to try to blast through a whole lot of stuff. Like missing data on the LASCO C3. But you can see ejecta coming out of both sides of the corona here, and some aspect of those coronal mass ejections must be headed toward Earth, as that is a nice shotgun blast. Here's what's going on with the fields. Again, we see no sunspots. That plage has a significant North Pole leading field and South Pole trailing field. We're getting some jack-o'-lantern-like effects here. Here's 304 angstroms. And there still are lots of filaments here, and those are best viewed in 304 angstroms. Next we've got, actually, I think we have 4 custom Helio viewer movies today. So here's one that includes the LASCO C2. As well as 171 angstroms. Here's just 304 angstroms of the North Pole area. Actually, the whole northern hemisphere. And you get a great view of that filament. Allow me to vanish. By the way, I'm highly skilled at vanishing, if you weren't aware. And again, here's this great filament eruption that we've caught here. There you go. Not really accompanied by a big solar flare, as the sun can fling plasma out into the solar system at any time without any real visible activity. There are some ways to forecast it, but if you can't see the filaments, you can't forecast it. And often we get coronal mass ejections that strike the magnetosphere that come from around the limb of the sun. Anyway, there's the 171 angstroms view of the exact same area and time frame. A great view of a bubble-like structure that kind of forms there. That's probably part of the... That looks like it's headed to the west to me, but it's very hard to say from this angle, as contrast plays a role when you're looking directly at a star. And lastly, we put up the 94 angstroms, which shows some great insights into another ionization state of iron. And you often see completely different phenomenon in the different wavelengths. 94 and 131 are specifically designed to study solar flares, coronal mass ejections, flux probes, and so on. 10.7 centimeter radial flux is still only at 70, so again, another example of you can see quite a bit of activity without a lot of certain statistics. So here you can see sunspot number 0, 10.7 centimeter radial flux, way down to, you know, what you would call solar minimum levels here, only at 70, as you can see. I'll move this back a little over 3 years, and then you can see pretty much hovering around 70 for 3 years. And so here we see the states of geomagnetic unrest and one of only 2 geomagnetic storms of the year 2020, that KP5 event. And then of course you see 2 more states of unrest, and we are in unrest right now without a whole lot of flaring happening, no sunspots. In any case, there's the X-ray flux, and you can see it's fairly flatlined here. Most of that activity is undoubtedly coming out of the plage that we've been showing you close-ups of. And we don't really see a big increase in the proton flux here. So these are all essentially flatlined events, and they're still causing KP5 events. So, you know, no big movements here in the proton flux, no big proton events whatsoever. And geomagnetic unrest, regardless. So we did see some ejecta strike right here, it looks like. This looks like an ejecta strike mode, like a coronal mass ejection. As you can see, the BT-BZ shifts right at the end of it. And it's very minor, but that is a sort of signature that you'll see with a weak, diffuse coronal mass ejection strike on the magnetosphere. Solar wind speed's been creeping down over the past 24 here, and we're at about 444 kilometers a second for the solar wind speed. Solar wind density around 10 protons per cubic centimeter. And the phi angles in the process of shifting. The BT-BZ have just gone to positive territory here. BT way up at 6, and that's a good thing. BZ positive 4, north solar polar field polarity. And I just decided to bring up this animation here on ISWA. Let me just check the life of the stream and reappear. This is just a great graphic. And yeah, solar coronal magnetic field. And it's similar to the Gong 2 stuff. And I figured I'd bring this up. Hopefully it's not making anybody dizzy or confused. I did not speed that up or anything. I just increased the amount of frames and the time frame. So, that's a good one. And things to note here are that you can see the way the north solar polar field lines look closed and the south ones look open. And that, you know, that's an indication that we're in the north solar polar current sheet, or that the current sheet is north solar polar field polarity, would be the best way to say it. So here's the magnetosphere, and again we see a sort of a steady stream of unrest here. And since the velocity has been ramping down, you should see this decrease a little bit toward the end. You see multiple new Van Allen belt layers form there as this happens, as the electrons struggle to meet the demand of all those protons. Here's what's going on the ground level, and I would expect to see some auroras. We'll actually show you the polar region also. Let me just load that, and then I'll bring this back. I'm bringing it back! And we can see significant perturbations there over a large portion of the Antarctican region, as well as over the north, and that's why we're going to show you the polar view. Not so much equatorial magnetic perturbation, and we typically, last year this time we did see a bunch in the South Pacific, and you see those pulses coming out of the South Pacific. We covered that regularly last year. Here's a view from the poles, and you can see the spiral-like nature of those magnetic perturbations. That all has to do with Earth's field-aligned currents, folks. As when the protons show up at the magnetosphere, they have to decide which field-aligned current they'll be in. And they've got to do it at very high speeds. So here's the GOES magnetometer, and you can see, as forecasted, it's pretty spiky here. It's not very smooth at all. And it's because there's a whole bunch of plasma between the Sun and the Earth, and it has not all yet ejected, although some of it, quite a bit of it, has. And there's still a significant series of filaments out there, and we could snap into the South Pole current sheet at any moment. So if you see the current sheet turns red right here, as forecasted also yesterday, that all has to do with that plage in the northern hemisphere. And yeah, the Earth could suddenly snap across as the plage is helping for the south solar polar field polarity to come through. This also demonstrates strength of the north solar polar field. Again, a good thing, as it's currently at 6 nanotesla. That's what you want to see. Now, I just wanted to, since I'm showing you perspective here, this is stereo A, by the way, so it's looking at the Sun in this sort of direction. This is stereo B. I just wanted to move this slide to this spot because stereo A is looking at the Sun from this angle, and that's why when we see coronal mass ejections headed this way, those are Earth-facing. Now, we don't see a lot of ejecta on stereo A today. I just wanted to give our new viewers some perspective. You can see there is actually some ejecta headed at stereo A also. You can see a faint halo up here, an indication that some of the plasma is headed directly toward the stereo A spacecraft, which, by the way, doesn't have a magnetosphere. It has electronics that tell its charge coupled device to turn off in an event called a CCD bakeout. Anyway, here's a line of sight field plot, and you can see the north solar polar field looking strong, and the south solar polar field partially covered up by the B field here. This could again change quite quickly, and you can see the perturbations in the B field here created associated with that plage. Again, not a sunspot, but still enough to really affect the environment. Now let's talk about some cosmology stuff. We're going to be talking about Sagittarius A star. Oh yeah, here are the X-ray transients from Sagittarius A star. You can see it's a fairly consistent X-ray source here over the past 14 years. And it's emitting X-rays in a fairly standard state right now according to the daily, these are days of the calendar here, so we're at day 245. And that's what smashlights is going to be all about today. Today's smashlights. We're going to be talking cosmology and basically only cosmology. We'll also be talking about whatever we want. So if something like this happens, instead of me being like, oh my God, I've got to take it out, I'm just going to take it out to dinner instead, because it's about as scary as it was to me on January 23rd. I would let you stay there, but you're kind of cramping my style. So if you'd be so kind as to, could you? Oh, thank you. See, I'm telling you, COVID is becoming very agreeable nowadays. So yeah, the whole Smashlight is basically going to be a cosmology segment today because, again, during the Smashlights we talk about whatever we want, and the news stories today are lacking. So let's talk about Sagittarius A star and its companion stars. Yes, so Sagittarius A star is the massive radio source at the core of the Milky Way galaxy. One of the largest stars in the whole galaxy is S2. Not only is it large, it's very strange. So looking at the Milky Way galaxy, you know, the galactic core is someplace in this void-like area, and it's because there's a lot of gas and dust there, which makes it look dark. If you zoom all the way in on Sagittarius A star, while it is an X-ray source, you will not see any sort of light emitted from it. I think this is S2 right here. And the reason that we're talking about this is because of the galactic wind, yes. So, S2 is an important part of the stellar system at the core of the galaxy. During its eccentric orbit, which has an eccentricity of 0.88, which is a highly eccentric orbit, I'll show you an image of it momentarily, it reaches speeds of 5,000 kilometers per second, over 10 times what the current solar wind speed is. So we're talking about protons with the solar wind speed, folks. This is a blue supergiant star, similar to Deneb, but orbiting Sagittarius A star at 11 million miles per hour. Why is that relevant? You may wonder why that's relevant. Well, it's because all stars, and there's a diagram of its orbit. It has a 16.8 year orbit, I think it is. Somewhere around there. 16.05 year orbit. So you can imagine what the tidal forces would be like there. And the thing to understand about this more than interesting system is that every one of those stars in that system has its own set of jets. So, for example, the Sun has enduring coronal holes at each of its poles. Now let's just make this up, as we don't exactly understand the magnetosphere of these. We're not looking at radio images. But this star right here, let's say that's S2. And let's say those are the stellar polar field regions. There are jets coming out of these areas. And I'm exaggerating their shape to make a point. These objects are probably quite similar to the Sun, but they're under incredible tidal forces, which is going to completely affect the input-output of these fields. And this is why the galactic wind has absolutely nothing to do with even the plane that Sagittarius A star is on. To make matters more interesting, the orbit of the Earth in the solar system and the orbit of the Sun around the Milky Way galaxy is off by like 40 degrees. And that is why the galactic wind has nothing to do with what's going on in the solar system. So again, now you see all these giant stars. This is a pretty zoomed in view here. And all of these giant stars, they all have their own enduring coronal hole fields that are blasting out beams of protons. At the very close layers, where you see these like double rings, very close up to these stars, there are electrical features happening there. There are atmospheres, we'll call them stellar spheres. And there's a massive amount of incredibly heated up gas and dust being blasted all around in different directions around here. And the galactic wind ultimately is the net effect of all of those objects. They all affect the output of Sagittarius A star, and Sagittarius A star affects the output of all of them. They're all within each other's magnetic fields to some degree. And the orientation of these poloidal fields is really what is important in terms of the proton output of these areas. In other words, if you have these three stars, where their poloidal fields are all aimed in the same direction, these fields will become like a woven together beam of doom, and it will be chased by electrons. Electrons will be pulled out of these systems and will chase those systems. And this is, I believe, how we get these pulsing systems. Now, exactly how the poloidal fields blast out these coronal holes constantly is still a matter of massive debate. But in any case, I hope that gives you some insight into what's going on in terms of the galactic wind. And by the way, the Milky Way galaxy is too complicated for the puny solar system and Earth to be directly affected by this. The energy from systems like this gets propagated through the giant poloidal fields, which are at a huge angle, by the way. You would think that because we've got Fermi bubbles like this, and you've got a bunch of different jets coming out like this, you would think this would be somewhat perpendicular to the galactic plane, and it is not at all. Sagittarius A star is off at a crazy angle. I think you can actually see some of the jets in this image. But it's off at a major angle, first of all. So, perpendicular to that would be like this, assuming that's the angle. It's hard to tell what orientation you're at here. And this is from a ground-based telescope. So, in any case, that's a little bit of what's going on. And by the way, the orientation of those poloidal fields doesn't necessarily have anything to do with their orbits. As we see, for instance, in the solar system, we see planets with their poles practically parallel to their orbital planes. So in any case, by the way, one of the tracks you just heard was Dr. Steelshank. It's an homage to Sam Afif. Go follow him on Facebook and tell him to stop being so cornea. He used to be the bacteria from Syria, and now he's just cornea from California. And that track is called Professor Krookenstein, and it's available at soundclick.com/goldencatproductions, our record label. And thanks to the gentleman who emailed me. By the way, we've also got a SoundCloud account. I believe that is in the links below the video as well. soundcloud.com/Daniel-Nigro-2. How catchy. I didn't come up with that. That was SoundCloud. Now, we are streaming live to Twitch. We love the platform. Twitch.tv/smAshomash. Thanks to our new subscriber or follower or whatever it's called over there. Cheers. If you haven't checked out our Cosmology playlists, check those out. There's all kinds of different stuff on there, from talk to coronal mass ejections to composites with a whole bunch of Helio viewers of the sun over a long period of time, such as 32 hours of the sun and stuff like that. Also, the video about the neutron star comet. There is a neutron star that's traveling at 141 kilometers a second across the Milky Way galaxy. Thanks to our YouTube subscribers. If you haven't pressed like and subscribe and press the notification bell to receive all notifications and hopefully, possibly even see when a video goes up, well, please do it now. No, that's okay. We'll wait. And oh, you're back. All right. Well, we welcome you. Oh my God, what has happened here? Son of my beehive. Have you pressed like and subscribe on YouTube? All right, thanks. And here ends today's Smash Lights. So we saw a big increase in the electron flux, and hey, you got to be wrong once in a while, and I was utterly wrong when I forecasted this yesterday. I expected electron flux to remain way down here, and it ended up way up here. So, cheers to NASA and NOAA. You were right, I was wrong. There's the graph of the past 3 days. They're calling for an increase in the electron flux still. I think this is because they're failing to forecast coronal mass ejection strikes. I don't know what's going on with it. I defer to their forecast. Next, looking at the total electron content visualization here. This is the whole air column. And we do see pretty high levels here, especially north of the equator here. Not so much south of the equator. It is still summer in the northern hemisphere after all. And we've changed the ionosphere data. So for all of our regular viewers out there, let me get rid of COVID. For all of our regular viewers out there, we usually show 6 hours of this. We've now switched it to 1 hour per second instead of 15 minutes per second and a whole day. So we just wanted to give people insight. Perhaps we'll switch this back. Leave us a comment. Let us know if you want to see a whole day of ionosphere or if you'd prefer to just see 6 hours. Maybe we'll leave this the way it is here, 1 hour per second for a full 24-hour period. It does give better insight into the whole thing. By the way, for you new viewers out there, the magnetotail would be where you see these red areas. That's the dark side of the planet, and this is the light side of the planet. The sun is shining about there. Anyway, here's the latest image, and it's looking pretty normal from my perspective. Looking pretty normal there at 8:30 Universal Time. Here's where planets are as Mercury swings around. There's where things will be in a week. If you're up before dawn, you may see Venus if you've got a telescope. Take an image. Send it to us at the smAsho VoIP line. It's country code 1. Area code 610-936-9799. That's country code 1. Area code 610-936-9799. Also, Mars is quite bright at a magnitude of -1.8. Next, looking at earthquakes, we haven't seen any large earthquakes. It's actually a lull in earthquake activity. Small deep quake over Alaska. I should say under Alaska. Shallow quake at Hawaii. Let's check which volcano this is under. I bet it's under Kilauea. And indeed, it's under the base of Mauna Loa there. Quite far from the caldera, but still 500 meters. About 1,500 feet above sea level. So quite a lull here in earthquake activity. Volcanoes are erupting. We're looking at volcanodiscovery.com here. To see Semaru exploding, 14,000 foot plume. I think that's an uptick since yesterday. Leave us a comment if I'm incorrect. Sangay, volcanic ash not observed in satellite. Please don't pole vault the caldera. Revenador exploding, flight level 160 there. Sabancaya exploding, flight level 260 there. 26,000 foot plume of ash is not something to hang glide over the top of. We still see major power outages here in the U.S. Let me press refresh just to make sure we're up to date. And we saw an increase over 100,000 out in Texas and still 358,000 out in Louisiana, also Arkansas. Power back on in the Northeast. California still showing 15,000. Let's talk about proxy data for a quick moment. One of the problems with trying to extrapolate great distances into the future or figure out what was happening in a great distance in the past. One of the problems is proxy data. Now this fire behind me doesn't make me mad. The fire behind me is not blue today. It's just my regular flamey self, not flaming. Proxy data can be a problem because when you're trying to figure out what was happening in terms of a very, very complicated system in which you don't necessarily understand all the data, proxy data can be an issue. If you don't understand what it is, it's trying to figure out what the carbon dioxide level was by basing it on temperature from 10,000 years ago, and so on and so forth. Counting tree rings, all these sorts of things are proxy data. Even fossils are proxy data. Ice cores are proxy data. And so some of the extrapolations of it turn to be out wrong sometimes, and that can be a problem. And that's all. That's the only comment I wanted to make. However, the implications of the possibility of a grand solar minimum are extreme. If you haven't read the paper that Zarkova printed on the 4th of August, I guess since you follow the channel, you should probably watch it. You should probably read the paper. As if we do see a grand solar minimum, and we need to wait about 5 years to be able to tell for real, because if you don't see 2 weak solar cycles in a row. In other words, if cycle 25 is stronger than cycle 24, and the only real way to tell is by the solar polar fields, but also sunspot number. If cycle 25 is weaker or about the same, approximately the same as cycle 24, you're in a grand solar minimum. If cycle 25 is slightly more activity than cycle 24, chances are you're not in a grand solar minimum. So the extrapolation of the solar polar field data is a bunch of math, and it's 100% theoretical. Since we don't even know how the solar polar magnetic fields are generated, suggesting that the dynamo model is able to forecast what the solar polar fields will do is, well, let's just say not appropriate. Maybe I should have put this in the cosmology segment, but this is part of climate also. Keep in mind also it takes thousands of years for ocean temperatures to catch up to solar activity, and it takes at least 2 or 3 years for solar cycle activities. In other words, you're going to be halfway up the ramp to solar maximum before you see the temperature start to increase, and one of the important things to watch is the Thermosphere Index, one of the true measurements of the temperature between Earth and Sun. Again, modern grand solar minimum will lead to terrestrial cooling. The paper by Valentina Zarkova, you should read it. Let's talk about positive and negative feedback systems. When you have more insects flying around and it increases your bird population because they consume more insects, that is a negative feedback mechanism in terms of insect populations. Sometimes a plethora of food or environmental conditions can cause runaway locusts. And if that just simply causes bird populations to increase for a couple years because of the extended food sources, that's a negative feedback mechanism. Let's talk about a positive feedback mechanism. Snow. Snow in the northern hemisphere is a positive feedback mechanism, and all proxy data seems to indicate that snow and the albedo effect is probably what causes iceberg Earths. So everybody who's very frightened that we may go into an ice age, a legit ice age, the feedback mechanism that's going to cause that, and has seemed to have caused it in the past, is the positive feedback mechanism of snow versus albedo. The more snow that falls in the northern hemisphere, the more light gets reflected back into space. COVID-19 is some sort of a feedback mechanism, and I have no idea what kind of feedback mechanism that is, but I'll give you some feedback. I didn't need to change anything. Do you think I went out and bought guns, or a hazmat suit, or a respirator, or had some prepped stuff like food and water, and just other random things that if we suddenly get a severe thunderstorm, I didn't have to go buy that stuff. All the people who went out and bought the stuff have increased their preparedness. This is a positive effect. Now, of course, it's not a positive feedback mechanism, because the only positive feedback mechanism when it comes to COVID-19 is the pathetic, infantile, and stupid response of governments, corporations, individual humans, and let's see, what else? Mainly governments and corporations. So anyway, back to snow. See that graph? That's like 2 standard deviations above the normal range. That is a 30-year average there, that light blue area. It's for the years 1982 to 2012. So that blue area, that's the 30-year average. You're clearly at least 2 standard deviations above that, and the last 2 winters before this looked like that also, which is why I'll forecast today that this coming winter will see less deviation above normal snowfall this year. It all has to do with the heat latency of the oceans, folks. And by the way, if you think the planet's warming or cooling or staying the same, and you're not measuring deep ocean temperatures, you have no idea what the Earth's temperature is in the first place. Does your doctor give you a breathalyzer to check your temperature at your when you go see the doctor, he takes your temperature? Does he give you a breathalyzer for that? No, I'll wait. I want an answer. Does your doctor give you a breathalyzer to check your temperature? Well, the reason he doesn't is because it's ineffective to check your temperature, and that is why it is ineffective to measure the Earth's temperature over any period of time to determine the temperature of the planet. You live in the atmosphere. Earth's heat latency lies in the oceans, and it takes actually thousands of years, apparently, for oceans to heat up and cool down from real heating and cooling events. And let me just put that out there, so you can. That's one to grow on, folks. That's a public service announcement by me at massive personal risk and expense. You're welcome. By the way, Laura could bring damaging impacts to the Northeast. Severe weather to disrupt activities in northern plains. And shout out to AccuWeather. Let's play a clip from one of their anchors. Now this guy's not quite as big as a house.
In the Northeast, and if you're in the Albany area, you've had severe weather today.
We had some severe weather last night. I slept right through a severe thunderstorm warning. I don't know what happened. Shout out to AccuWeather. Anyway, the storm track has changed. If you're in the Northeast, if you're one of our Mid-Atlantic viewers, you may get rained on or something. Now, everybody overreacts a little bit to weather threats, and that's within reason. You notice that snow forecast and everything gets over-forecasted. It's better to over-prepare than under-prepare, right? Let's look at pressure maps here on Witty.com. We're back to real-time data here. And we're letting this advance via the GFS forecast, as we do most days. And we see a very powerful low-pressure system here moving onto the Alaskan Peninsula there. Very strong low-pressure system there. Don't be surprised to see an earthquake in Alaska, especially with this lull in earthquakes. Here's where we expect things to be at 12 noon tomorrow, my time. And if you're wondering where I'm located, that's close enough. It's around here in Lehigh Valley, Pennsylvania. Man, that's too small of a dot. That's about the Lehigh Valley. Cheers. And shout out to our local viewers. Shout out to Granddad. Thanks for watching the daily space weather videos. Lightningmaps.org is showing us some terrestrial lightning here in the U.S. Let's do shout outs. I'm shouting out Memphis. I'm shouting out Nashville and Oklahoma City. If you're in Oklahoma City, go outside and look to your southeast. you're probably out of the crosshairs, and there is quite a show going on. Leave us a comment if you've been to Oklahoma City. I was there in 1998 as I drove from Allentown to San Diego. Shout out to all of our European and African viewers. There are your water vapor maps. Shout out to our Far Eastern and Oceanic viewers. By the way, this is Oceania, this area right here. I don't know what it's called. Look, I call this Oceania, and I call this the Far East. Deal with it. And we do see a system happening here. Oh my gosh. By the way, I forgot to talk about movie recommendations today. We'll have to cover that tomorrow. Or maybe I'll make a separate video. A second Smash Lights. Here's what's going on in the water vapor map over the Americas. And you can see that Borg sphere is still circling the northern hemisphere. We're not sure if it's going to try to assimilate us or not. Ha 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 ha! Just kidding. Here's a U.S. Doppler radar map, and we see some heavy storms here over the south-central regions. Here's what's going on in the cloud layer. And let's zoom in on the Texarkana region. By the way, I'm moving to Texas tomorrow, so we'll be on Central Time. Just kidding, folks. Just kidding. Anyway, that's what's going on in the cloud layer. Even though it's dark, we use the NASA GOES shortwave infrared. As water emits radiation, did you know? A lot of radio astronomers don't seem to know. Just kidding, folks. Radio astronomers know. They might not know as well as Robitaille, but they definitely know. Here's what's going on over Texarkana and water vapor. Again, shout out to our viewers from the U.S. South. There will be massive pressure gradients in these areas. If you're flying an airplane like this, you will see some turbulence, to say the least. Next, looking at nullschool.net. Was this the Don Lemon? The Don Lemon anticyclone is large and in charge down there, unlike Don Lemon, former journalist. Or a guy that isn't a journalist, but he plays one in real life. Pretty crazy jet streams over the U.S. here. And it looks like it's going to be making for some cold temperatures over the northern Great Lakes area. You're getting some central Canadian air there. A bunch of hoofty air, eh? A bunch of air from the hosers of central Canada. Please leave us a comment if you're from Canada or central Canada. Crazy jet stream maneuvers over here too. Check this out. Bizarre jet stream right there and there. Very concentrated. Moving due north and south. It's meridional solar minimum jet stream flow at its finest. By the way, thanks to our subscribe stars and to our patrons, the true source of funding for the content. Please consider becoming a patron if you haven't already done so. We're growing our organization. If you're getting at the ground level, you may learn things you wouldn't otherwise know. And allow me to go back to my home plane of existence. I decided to broadcast not from the Smash bunker today. Can you hear the crickets? I don't think so. There's a hum of some kind of motor or something. Thanks to the Smash team for tuning in. Please don't forget to share on your social media, etc. Press like and subscribe. And head to smashamash.org and check out the links to support the channel via affiliate links, Smash Store. Thanks to Mary Wright, who I think bought a 3C405 shirt. We'll be waiting to see a photo, because if there's no photo, it never happened. Thanks for flying American Smashways. Please keep your head and arms inside the Smash plane at all times. Here's a composite image. There's the latest in 211, 193, and 171 angstroms all at once. I like it. A great view of that plage there. which never really became a sunspot. Let's look at 193 angstroms as we see some coronal holes rotating out as their wind streams arrive. And we'll also show you, as we usually do, the colorized magnetogram and the intensitygram to show you 0 sunspots. Here's a colorized magnetogram. So lots of magnetism happening there, no sunspots. And I did see a dark spot this morning when I was doing show prep. Pretty sure that is now gone. So here's the latest image on the intensitygram. And I'm not seeing any dark spots there. What say you? Let me zoom back out. And that's 4,048 pixels, I think. 4,096 pixels. And last but not least, here's the 193 angstroms view. And the wind streams from those coronal holes there in the north are not here yet. Expect those in about 2 days. And we've already had a bunch of coronal hole wind streams hitting. There's also ejecta from coronal mass ejections on the way. Don't be surprised to see geomagnetic unrest conditions come back. Don't be surprised to see the electron flux completely crater, as I'm surprised it's as high as it is. Don't be a stranger. Check out our playlists. Check out our other links at smAsho.org. Thanks for tuning in. Stare at the sun, don't drink, and if you do, don't drive. Welcome to the Neo-Renaissance. We hope you enjoyed today's Sunday special. And since it'll never be now again, may that solar wind be at your back and that covidiousy absent from your locale.